Hello, I'm Ahmet Rabay. I'm studying industrial engineering at Bilkent University. Today, I'm gonna talk about my Physics 102 project, which is the proof of Kirchhoff's laws in different resistance values. First of all, Kirchhoff's laws consist of two stages. The first law, which is the junction rule, says the sum of the entering currents in a node is equal to the sum of the exiting currents. And the second rule, which is the loop rule, says the sum of the potential differences in a loop equals 0. In order to observe the application of Kirchhoff's laws, I built two setups. I used 220 and 680 ohms resistors and 5k ohms potentiometer, and I connected them in parallel. In that way, I observed the junction rule. My hypothesis was the sum of the currents that passes through on each resistors should be equal to current on initial node. Secondly, I built my other setup to observe the loop rule. I used 10k and 46k ohms resistors and 1k ohms potentiometer. I changed the resistance by using the switch of the potentiometer in both stages. In that part, I connected the resistors and potentiometer in series. And my hypothesis was the sum of each potential difference between devices should be equal to EMF. So I used 12 ohms power supply as EMF and multimeters for my measurements. Okay, let's get started. I use power supply, a board, resistances and a potentiometer in my projects. Okay, now we will prove the Kirchhoff's first law, which is the junction rule. As we said before, the current that passes from the potentiometer will be changed as we change its resistance, but others will be remain same because of the Ohm's law. And as you will see by the Kirchhoff's junction rule, the sum of the currents that passes through each resistance will be equal to current on initial node. Here you see, as we change the resistance, the current on the initial node always be equal to sum of the currents that flows on each resistance. Okay, let's move to the second part. Now, we are going to observe the Kirchhoff's second law, which is the loop rule. Kirchhoff argues that in any circuit, the sum of the potential differences of each devices are equal to EMF. In our case, it is equal to 12 volt that we set in our power supply. Now, we take our data with 10k and 47k ohms resistances and a 10k ohms potentiometer. We will connect these resistances in series and measure each of their potential differences. As you see, we change the resistance of the potentiometer. And voltages of resistances will be changed by the Ohm's law, but their sum will be always equal to EMF, that is 12 volts in our case. Thank you for watching.